Hi YouTube, Tim Unkert here. In this video, we're going to factor quadratic so we can find the zeros, the solutions to the quadratic. So you see here in problem 1, it says solve for x. So what they want us to do is find the two x values that satisfy the equation. So we have this equation, x squared minus 2x minus 15 equals 0. So I'm going to list the factors of negative 15. So those are negative 1 times positive 15, 1 times negative 15, negative 3 times positive 5, and positive 3 times negative 5. Now I note with this last pair of factors here, those add to negative 2, which is my middle number here. And that's what I want. So I'm going to select positive 3 here and negative 5. And I'm going to write my factored form as x plus 3 times x minus 5, and that's all equal to 0. Okay, so now what I'm going to do is use the zero product property and set each of these factors equal to 0 to solve for x. So I'm going to set x plus 3 equal to 0, and I'm going to subtract 3 from both sides, and I'm going to get x equals negative 3. And I'm also going to set x minus 5 equal to 0. And I'm going to add 5 to both sides. And I'm going to get x equals 5. Okay, so my two solutions are x equals negative 3 and x equals 5. Okay, so that's that first one. Now stick around for the end of the video because when we work through these, I'm going to show you a quick way using Desmos to find the zeros to a quadratic. Okay, so let's look at the second one here. We have x squared minus 5x equals 36. So to solve for x, the first thing I need to do is get one side equal to 0. So I'm going to subtract 36 from both sides here. So on the one side we have this equal to 0. 36 isn't like x squared or negative 5x. So on the left-hand side we have x squared minus 5x minus 36. Okay, so now we want to look at the pair of factors that multiplies to negative 36 and adds to negative 5. And that's going to be positive 4 times negative 9. Now sometimes it may take some practice listing out the factors to figure out which pair works. But as you get more experienced, you'll see this a lot quicker. In this first one, I listed out all the factors, but if you know which ones those are, no reason to list out all the factors. Just list out the pair that works. So again, negative 9 and positive 4, they add to negative 5 here. So I'm going to use those, and I'm going to write this in factored form as x plus 4 times x minus 9, and set that equal to 0. Okay, so now what we're going to do is set both of these factors equal to 0 to solve for x. So we set x plus 4 equal to 0. And when I say you can do this using the zero product property, what I mean here is that if this is equal to 0, this entire thing is equal to 0, like we set it here, then 0 times whatever this is will equal 0. Likewise, if this here is set to 0, which we're going to set to 0 also to solve for x, 0 times whatever this is will also equal 0. So that's the zero product property. Okay. X plus 4 equals 0 here, so we're going to subtract 4 from both sides, and we're going to get x equals negative 4. Here we're going to set x minus 9 equal to 0, and we'll add 9 to both sides, and we'll get x equals 9. Okay, so our two solutions here are negative 4 and positive 9. Okay, let's move to problem 3. So problem 3 is interesting. There's a couple different ways we could solve this. Okay, we could factor out the common factor here. So everything here is divisible by 2. So I could rewrite this as 2 times x squared minus 16. Set that equal to 0. I could note that these are both perfect squares, and here's a subtraction sign. So this is a difference of squares. I do have videos on my channel on this. So you can factor it into 2 times x plus 4 times x minus 4. Set that equal to 0. Obviously, you can't set 2 equal to 0, but you can set x plus 4 equal to 0 and x minus 4 equal to 0. So if I say x plus 4 equals 0, I'm going to subtract 4 from both sides, and I'm going to get x equals negative 4. Here, I'll set x minus 4 equal to 0. I'll add 4 to both sides, and I'll set, and x will be equal to 4. So x equals negative 4 and x equals 4. That's one way to solve it, okay? I'm going to erase this stuff now and show you a different way. Okay, a different way is to add 32 to both sides. Now, I said you do want one side equal to 0, but in this case, I'm going to add 32 because I see something. So I get 2x squared equals 32, okay? If I divide both sides by 2, I get x squared equals 16. So you can solve quadratics of this form by taking square roots. So if I take the square root of both sides, I get x equals, now square root of 16 could be positive or negative 4, so it could be plus or minus 4. And that's how we get the negative 4 and the positive 4. So that's an alternative way to solve problem 3. It's a little bit different, okay? Now let's look at problem 4. So in problem 4, I do want to get this 20 to the other side, so I'm going to subtract 20 from both sides. 20 is not like any of the other terms, so I'll have 24x squared minus 52x minus 20, that's equal to 0. Okay, so now I'm looking at this and thinking I probably have a common factor that I can divide out of all these terms. I can at least factor out a 2. Let's see, can I factor out a 4? Is 52 divisible by 4? And if I look at it, it turns out, yes, 1 times 4 is 4, so 5 minus 4 is 1. We get 12 here, and 4 goes in exactly 3 times. So I'm going to factor out a 4. So if I factor out a 4, I get 6x minus 6x squared minus 13x minus 5 is equal to 0. Okay, so from here, I want to list out the factors of 6. Those are 1 and 6 and 2 and 3. Okay. And also the factors of negative 5, which are 1 and negative 5, and negative 1 and positive 5. And now I'm thinking, can I get a combination that adds to negative 13 when I add the two products? So if I do negative 5 times 3, that gives me negative 15. And then positive 1 times 2, that gives me positive 2. Negative 15 plus 2 is negative 13. Okay? So in factored form, we're going to write this as 4 times 2x. These are going to be my coefficients, 2 and 3. And then over here, I'm going to have a 3x. I want to have the negative 5 multiplied by the 3. So I have to put it here because remember the inner terms will multiply. And I want to have the positive 1 multiplied by 2. So I'm going to put it over here because the outer terms also multiply. And remember, that's equal to 0. Okay, I'm just going to erase some stuff from problem 3 so we can make some room because this one's taking a little bit more space. Okay, so now what I do is I'll set each of these. Obviously, you can't set 4 equal to 0, so I'm going to set 2x minus 5 equal to 0. I'll add 5 to both sides. So I'll get 2x equals 5. Divide both sides by 2. These will cancel. You get x equals 5/2 or 2.5. And then for this other one, we have 3x plus 1 is equal to 0. I'm going to subtract 1 from both sides. I'll get 3x equals negative 1. I'll divide both sides by 3. and I'll get x equals negative 1/3, or negative 0.3 repeating. Okay, so that's one way you can do it. Now, if you're taking a test like the SAT where they allow you to use the Desmos graphing calculator, one thing you could do is I could take this here, 24x squared minus 52x equal to 20. Let me just get rid of that. So 24x squared. Let me zoom in here a little bit for this. So it's 24x squared minus 52x equals 20. Okay, and then I look for where it crosses the x-axis. So I see it crosses at negative 0.3 repeating. That's one of my x values, and it also crosses at 2.5. Okay, so that is another way that I can find my solutions. The solutions are called the zeros to the quadratic, are where the quadratic crosses the x-axis, are the x values where it crosses. Okay. Hopefully this video was helpful to you. If it was, please like and subscribe if you haven't done so already. Also, if you want to support the channel in an alternative way, I'll leave a link to my Teacher Pay Teacher store in the description. I'll also leave a link to my website, which has a lot of cool math stuff in the description as well. Hope to see you in the next video. Have a great day. Bye.